All right, in this video I'm going to talk about dipole-dipole interaction, ion-dipole interaction, and ion-ion interaction. These are basically ways that polar molecules are going to interact with each other, or ions are going to interact with each other. So the first one here, dipole-dipole interaction. So if there's a polar covalent bond in an asymmetric shape, a dipole will form in a molecule. This means that one end of the molecule will be slightly positive and the other one will be slightly negative. So here's oxygen and its hydrogens. And this end is partially negative and this end is partially positive because oxygen likes the electrons more than the hydrogen, and so when he pulls them up, and because of the asymmetric shape, he's pulling them more in this direction than any other direction. This end starts being partially negative and this is left as partially positive. If we have two water molecules and these oppositely charged dipoles see each other, then they can have an electrostatic attraction to one another. The partially positive will be slightly attracted to the partially negative. This is called a dipole-dipole interaction because both molecules have dipoles that are interacting with each other. This particular dipole-dipole interaction is a hydrogen bond, and this is important because hydrogen is very small. See, these hydrogens are very small as far as atoms go, and these are lone electron pairs. So when these interact with each other in a hydrogen bond, the hydrogen and the oxygen lone electron pairs can get a lot closer than usual. You might recall that when things get closer, their forces get stronger. So a closer interaction means a stronger attraction. And so this is what leads to the observable very high boiling point for water specifically, right? So that's why it's all the way up to 100 degrees Celsius, because when these interact, there's a dipole-dipole interaction, but it's a stronger than usual dipole-dipole interaction because hydrogen's small and that's a lone electron pair, so they can get even closer, and when things get closer, they have even more interaction. So what else do we have here? Dipole-ion interaction. So this is when an ion from an ionic crystal, let's say somebody like sodium, is interacting with a dipole in something like water. And this is the interaction that's going to lead to this salt crystal being soluble. So if we imagine water has a partially positive and partially negative end, the oxygen is partially negative, the hydrogen is partially positive, then we can have an interaction between that water molecule and the sodium molecule. And it doesn't just have to be one, we can have many water molecules interacting with that sodium molecule in these ion-dipole interactions. Now this sodium chloride is part of a bigger crystal, and so it has a fairly strong attraction to its own crystal, but if enough water molecules come along and work together, then they can actually pull that sodium right out of its crystal. And what that leads to then is the crystal dissolving. So that's how the ion-dipole interaction can be responsible for the solubility of an ionic crystal in a substance like water. Finally, ion-ion interaction. So, again, when we have our sodium chloride crystal, the reason that this is a hard, high melting point solid substance is because each one of these ions is electrostatically attracted to the other ions in the crystal. So this interaction right here, where these guys, he's positive and he's negative, he's positive and he's negative, so that interaction right there, that is called an ion-ion interaction. And we can think of solubility as kind of the competition between this and ion dipole. Are the dipoles strong enough to pull away? Are there enough dipoles to pull them away? Or are there too many ions such that they can clump together and crystallize and form a solid crystal? And that's the sort of competition to determine whether or not ionic substances will be solid and not dissolve in a solution, or whether they will dissolve in a solution. That's why when you boil the water out of salt water, eventually the salt will recrystallize because of its ion-ion interaction, or why a different ionic crystal, say something like calcium carbonate, with its large charged ions, just has too much ion-ion interaction to be soluble. See, these charges are large, making ion-ion interaction stronger, and so this is insoluble as the ion-dipole interaction is not strong enough to overcome the ion-ion interaction. So there you go, a dipole with itself, or a dipole with some other dipole, that's dipole-dipole. An ion with a dipole, that's like water with the sodium from a salt crystal. And then finally, ion-ion, when you have the two ions that resulted from an ionic bond being electrostatically attracted to each other because they're opposite charges.